Good day, everyone. I'm Ethan, moderator for this webinar. Welcome, everyone, for today's webinar, Validation of HPLC or UPLC Methodologies. I would now like to introduce our presenter for today, John Fetzer. John C. Fetzer has over 30 years of experience in HPLC methods development. I would now like to hand over the floor to the speaker. Over to you, John.
Good day, everyone. This is a webinar on issues in method validation related to instrumentation and operational issues. Schematic of a generic liquid chromatography system. And this is just a little verbiage to describe that, segmenting the problem. Solvent problems are an area that's often overlooked. Pumps. Everyone has a pump of some type. The most common ones in liquid chromatography are piston pumps. Is a dual piston one, and this is a schematic image of one. Some of the things that are overlooked in pump things. One is very fundamental. Flow accuracy. These are the values for A-grade volumetric flasks and cylinders. There is a simple way that many auditors accept if they understand the chromatography, is the pressure that builds up when you put something to impede the flow. This is a slide showing one of the problems with that pressure is another mechanical device, and most people ignore the injectors. They're just devices that work in their chromatograph. Some problems that people miss when they're doing it, injection accuracy that people often use is what is stated by the manufacturer. Column problems are varied and numerous. Once you've decided on a column, which in itself is one of the issues in method validation that gets overlooked, because an auditor may ask you why you chose a particular column, because increasing tailing implies that something is going on more than likely with your column, flushing off the column with a strong solvent mixture, a strong mobile phase at some point to get everything off, and then you re-equilibrate it. Detector problems are also an issue. With UV detectors, wavelength accuracy is something that needs to be determined. Most people now use diode array-based detectors or photodiode array detectors that go by different acronyms or abbreviations, which I show in the next schematic. This is actually an Agilent diode array design. Fluorescence has similar issues as far as bandpass, except for one huge caveat. Many manufacturers of fluorescence detectors do not go with narrow bandpass. In order to increase the claim sensitivity of their fluorescence detectors, they use wide band passes, wide ranges going through the emission monochromator or the mass spec. I'll go on briefly. There are many things that go on with mass spectrometers that can be issues, and that may cause some problems as far as the splitting ratio or lead to a surface material that may actually affect the composition. One big caveat that runs into play with mass spectral detection that is very commonly used is electron impact. Electron impact is used because you're breaking the molecule up with energy. It's typically using highly charged plates. As an example, this is just assessing the chromatography I touched on briefly. This is how you determine tailing. These are some causes. You have adsorbed sample, as I've talked about. So tailing is something you should be monitoring. Resolution is described by this formula. Some people just something in their sample that is very closely eluting. They just look and see if they're still baseline separated. These two slides are the two calculations for plate count. Use whichever one. If your column manufacturer gives you a model compound with plate count on it, baseline settings. Every instrument manufacturer has baseline settings or settings that they have as default. in their instruments. So it's what they ship. Peak in this chromatogram is an unresolved peak. And these are some way data systems integrate those. This is just a really horrible example in the literature of what happens if you have a forced baseline, and you can see that all these peaks are being quantified at very poor amounts because they're missing. And this option is available in many chromatographs. One, thank you for your attention.
Thanks, John. That was a wonderful webinar. Thank you, everyone, for participating. And thank you, everyone. Thank you, John, for the last minute cover. Okay. You all may disconnect now, and you all have a great day ahead. Bye-bye. Take care.
Have a great day. See you.
Thank you.